Hey gang, I want to look at something called statistical inference in the next couple of videos. The first video that we create here, we're going to talk a little bit about a real basic introduction to confidence intervals. And then later on, we're going to do a real basic introduction to hypothesis testing. So starting off here, just statistical inference, what does that mean? So that means that we're drawing conclusions about a population from sample data. Okay, so a lot of times we can't get the entire population's worth of data to analyze. We might need to collect a sample, but we still want to be able to talk about the mean and the standard deviation or different probabilities of that population. And so we do that through what's called statistical inference. So one thing we're going to focus on here is a confidence interval. So I just want you to focus on this section right here, the estimate plus or minus the margin of error. Okay, that's the general idea of a confidence interval. Is we're going to come up with some estimate from our sample, and we're going to add and subtract some margin of error because it is a sample, and so we don't know. Maybe we got a bad sample, so we want to have this margin of error that we add and subtract to each side. To give us a little bit of wiggle room, and hopefully we'll still be able to capture that true value that we're looking for. Okay, so what is the margin of error? Well, the margin of error describes how far we would expect the estimate to vary from the true population. Okay, so as an example here, here we have an article from Pew Research, and they did this fictional polling here. So this is not a real poll, but in poll A, the Democratic candidate received 43% and the Republican candidate received 48%. Okay, but there's this margin of error of 3 percentage points. Okay, so that means that the Democrat, even though the results of the poll showed them at 43%, we would expect that maybe it's down at 40% or maybe it's up at 46%. We've got some uncertainty there. Okay. The Republican, meanwhile, if we go up 3%, takes them to 51%, and down 3% takes it to 45%. Okay. What we notice here is that this is basically a confidence interval for each one, and the two confidence intervals overlap. Okay. So in this case, for poll A, we can't be certain that people prefer the Republican candidate to the Democratic candidate. It's possible with the margin of error that we actually have 46% of people supporting the Democratic candidate and only 45% of people supporting the Republican candidate. Okay. If we come over here to poll B, though, now the Democratic candidate is still the same. The Republican candidate here polled at 51%. And so if we go up 3%, we're at 54, and down 3%, we're at 48. Now there is no overlap between these intervals. Based on our confidence interval, we would expect the highest the Democrat might be polling at is 46%, and the lowest the Republican might be polling at is 48%. So if we had these poll results with this margin of error, this is a case where we could feel pretty certain that people preferred the Republican candidate to the Democratic candidate. Okay, and that's kind of what confidence intervals let us do. They let us sort of estimate that true value we're looking for, in this case the true proportion of people that prefer a specific candidate. Okay, and it gives us a range of values because of the uncertainty. But then if we've got multiple confidence intervals, we can use those to compare. And if there's no overlap, we can say that there is probably a difference between the two. Okay, so let me just come back here. We want to talk about a little bit about interpreting a confidence interval and a confidence level. And we're going to look at a specific problem or two where we talk about these different things, but I just want to go through them briefly here. So interpreting a confidence interval. So what we're going to do in this class is we're only really going to look at 95%. We're going to stick with 95%. So we're going to say we are 95% confident that the interval from, and then we're going to have some lower bound and some upper bound, captures the true and then value whatever we're looking for. So in the polling example, we could say we are 95% confident that the interval from 48% to 54% captures the true proportion of people who support a Republican candidate. Okay? That's how we would interpret that confidence interval. The confidence level, this is one that's often tricky for people to understand. Okay? If we were to construct many 95% confidence intervals, okay, so we're constructing a lot of them, about 95% of the intervals would capture the true value. So in this case, maybe the true proportion of people that support a Republican candidate. Okay, so again, we're saying the confidence level means that if we did this a whole bunch of times, many times, we would expect that about 95%, or whatever our confidence level is, about 95% of those intervals would capture the true value that we're interested in. Okay? Which means there are still some confidence intervals that we would create using this method that wouldn't capture that true value. So it's possible maybe the true value of people that support a Republican is actually only 45%. Well, that one confidence interval that we looked at that went from 48 to 54% doesn't capture the true proportion. And that's possible. And we'll look at how do we make it more likely that we'll capture the true proportion, or less likely. What happens when we increase the confidence level or decrease the confidence level? Okay. So one other thing I just want to look at very briefly here is this right here. This is really all we're going to use for this class. X bar, that's going to be our estimate. So our estimate of the average, the mean, plus or minus this Z star. We'll talk about that, but we're going to use 2 for that, just the number 2. And then sigma is the population standard deviation over the square root of n, and n is your sample size. Okay, so this is the only formula really that we're going to be using here. Okay, so let's go back and let's look at an example here. So here's an example where the confidence level is 95%. We're taking samples of size 5, so not very big samples, and we could sample that. So this first sample, you can see the 5 dots. Okay, those are the 5 values. And our confidence interval would go from the end of the left bar to the end of the right bar. Notice this green line, the mean, does overlap that confidence interval. So that means our confidence interval did capture the mean in this case. Okay, we could do it again. This one also captured the mean because it's overlapping. Our confidence interval is overlapping the mean. We can keep doing this, and eventually we're going to get some confidence interval that doesn't overlap the mean. So here's one that doesn't. See, we had this dot way down here to the left, and that really brought that confidence interval towards the left side of our graph here. And so we had this is one example where our 95% confidence interval does not capture the mean. Okay, and we could do this a whole bunch of times. We could do sample 25 at a time. So if I keep doing this, keep sampling 25, you can see every once in a while we get 1 or 2 that don't actually capture the mean. And they actually keep this running total down here. You can see right now it's at 96%. Okay, so we don't expect it to work exactly out to 95%, but the more times we do this, we should end up getting closer and closer, hopefully, to around 95% here. Okay. Here's another website that kind of shows the same thing. So we've got a 95% confidence interval, and if I play this, it's just constructing a whole bunch of 95% confidence intervals. The ones in red are the ones that missed capturing the mean, the true mean. The ones in black are one that did. And we can see right here that right now it's only at about 93% that are actually capturing. And we would expect, as it's going up here, that over the long run, 95% of these confidence intervals would capture the true mean. So what happens if we increase our confidence level? So rather than being 95% confident we've captured the true mean, We want to be 98% confident, so even more confident. So think about what would happen there. If you want to be more confident, okay, so let's say that you want to guess the population of a particular city, okay, and you want to be, I'm going to let you give me a range. Okay? You want to be pretty certain that your range, 98% confident that your range contains the population of that city. Well, what are you going to do? You're probably going to make that range larger. So let's see what happens as we take this up to 98%. Okay? We can see those bars just got wider. Okay? If I said you only have to be 50% confident that your range is going to capture the population, well, now that means that 50% confident, you expect to be wrong half the time. So that confidence interval, if I take this down to 50%, those confidence intervals shrink quite a bit. Notice a lot more of them are red, about half of them, because we would expect to be wrong half the time. Okay? So why wouldn't we just make it as make ourselves as confident as we want? Well, because then we have to make our confidence interval larger. Okay? A smaller confidence interval makes us seem a little bit more certain, except that we're going to be wrong more often. Okay? So in the next video, I'm going to go through some specific examples for calculating confidence intervals.